Good morning. We're going to go over circles today, specifically the center radius form of a circle, and we'll do a word problem, and then you'll do some practice on MyOpenMath. So what exactly is a circle? Well, by definition, a circle is the set of all the points that lie a given distance away from a given point. These points are in the same plane, and this given point is called the center of the circle. The distance is called the radius of the circle. So here's a picture of what I'm talking about. So what you see here is a circle consisting of all the points that are 3 units away from the center, which is located at the origin. So we would say the center of this circle is at 0, 0, and it has a radius of 3. Now when you're writing the equations of circles, it's really important to pay attention to where is the center and how much or how long is the radius. And the reason is because all circles are in the form of x minus h quantity squared plus y minus k quantity squared equals r squared. This is called the center radius form. And hk is the x and y coordinate of our center. Now they do notice down here that the circles that have a center at 0, 0, they're not going to bother writing x minus 0 squared plus y minus 0 squared. They're just going to go ahead and write it as x squared plus y squared equals r squared. So let's look at this example here. We are to find the center radius form of a circle with a center at negative 3, 4 and a radius of 6. So we know what the center is. We know how long the radius is. And now we're going to work with the generic version of our center radius form of a circle. You are not replacing x and y. You are replacing h and k. Those are the x and y coordinates of the center. So we replace h with negative 3 and k with 4 and r with 6. We do a little simplification of what we have, and we end up with x plus 3 quantity squared plus y minus 4 quantity squared equals 36. And that's our center radius form of that particular circle. Here's another one. This one has a center at 0, 0 with a radius of 3. Now remember, because our center is at 0, 0, we are not going to bother writing x minus 0 squared and y minus 0 squared. We're just going to write it as x squared plus y squared equals r squared, which turns into x plus y, or x squared plus y squared equals 9. Now we're going to go from the writing the center radius form of a circle to graphing the circle. So what we need to get information-wise is what's the center of the circle and how long is the radius. Now you probably won't need to write this down, but if you do, that's okay. But your thought process should look like what appears on the screen here. That's how you're going to figure out that the center is located at negative 3, 4. And by taking the square root of 36, we know that 6 is our radius. So when we graph the circle, we'll locate the center first, negative 3, 4. And then we'll count to the left 6, put a dot, count up 6, put a dot, count to the right 6, put a dot, and count down 6 and put a dot. And then we'll just connect our dots there. And that connection of all of our dots then would be our circle. So there's the circle that matches the equation, x plus 3 quantity squared plus y minus 4 quantity squared equals 36. Got a center at negative 3, 4 and a radius of 6. Here's another circle, x squared plus y squared equals 9. So because it doesn't have an x minus or a y minus, we know the center is at 0, 0. By taking the square root of 9, we have a radius of 3. So we just start at the center, 0, 0, count out 3, to the left, to the right, count up and down 3, connect those 4 points, and we've got our circle. Now here's a word problem. This has to do with an earthquake. So how do they determine where the epicenter of an earthquake is located? Well, in this case, there are 3 receiving stations. So these 3 stations feel the vibrations from the earthquake. And based on their data, they know that the distance from the epicenter to their station is 2 units, 5 units, and 4 units. So one station is located at the point 14. It determined that the epicenter was 2 units away. A second station is located at the point -3, -1. According to their data, the earthquake's epicenter was 5 units away. And the third station is located at 5.2, and their data indicated the epicenter was 4 units away. So what we're going to do is graph the 3 circles. And once we look at the graph, we'll see that these 3 circles all intersect at the point 1, 2. Well, that intersection is actually the epicenter. And we'll check that algebraically by substituting in that particular x value and y value and seeing if we get a true equation. So here's our graph. We've got the point 1, 4, we've got the point 5, 2, and the point -3, -1. So station A, that's the blue circle, we're going to replace x and y with the points 1 and 2 and see if the left side of the equation equals the right side of the equation. It does. You can see that it does equal the right side of the equation. So the point 1, 2 is valid for this circle with the center at 1, 4. Now we check station B, the one that's located at -3, -1. Again, we replace x and y with the point 1 and 2 and see if the left side of the equation is equal to the right side of the equation, which it is. Check station C for the same thing. Replace x and y with the point 1, 2, and the right side of the equation does equal the left side of the equation. So what that means is the point 1, 2 is on the circle A, it's on the circle B, and it's on the circle C. Well, if one point is on all 3 circles, that must be where the epicenter is located. That's all I have today. So now you're going to go to MyOpenMath and do the assignment that's titled 2.2 Circles. Have a great day.